Stereo image widening is the process of changing the perceived stereo width of an audio signal. Engineers will use this effect whenever they like to make a signal appear as though it's narrower or focused, or wider and spread out. This type of effect shows up in several common audio plugins. This effect is created by using mid-side processing. First, mid-side encoding is performed, and then the relative amplitude of the mid-channel and the sides channels are changed. Then, mid-side decoding is performed to recover a new left channel and right channel. First, let's open up our digital audio workstation and look at several common audio plugins that perform stereo image widening. Then, we'll jump over to MATLAB and write our own computer code to create this effect. Here in our digital audio workstation, let's look at a couple different examples of stereo image widening plugins. I'm going to be working with the stereo sound file of a drum recording. It sounds like this. The first plugin we can look at is Ozone 6 from Isotope. One of the modules in the plugin is called an imager. As part of this module, there's a fader that can be used to widen or narrow the stereo field. It sounds like this. Next, we can look at a different plugin. This is the S1 imager from Waves. It also has a fader that can be used to change the stereo width. In both cases, the fader gives the engineer continuous control from a very narrow stereo field to an extra wide stereo field. We like to be able to recreate this using our own computer code. Let's go ahead and open up MATLAB and look at how we can recreate this effect. To change the perceived width of the stereo field, we're going to make use of mid-side processing. In a previous video, I started this script, and I already set up mid-side encoding and mid-side decoding. I left this section blank here for additional processing. In this case, we're going to insert some commands in here that are going to change the relative amplitude of the mid-channel and sides channel. I'll start out with by introducing a new variable called width. Conceptually, this is going to be used for how wide or narrow we'd like our stereo width to be. Start out by assigning it a value of 1. We'll make a comment here about the range that it can have. So our width variable can take on a range from 0, meaning as narrow as possible, and 2 being extra wide. And we'll stick to this range. Now we can make use of this variable to process or change the relative amplitude of the mid and sides. So to begin with, let's go in here and overwrite the sides variable. I'm multiplying by the width. The width times the sides. And we'll overwrite the mid variable. Again, these are arrays or signals. In this case, what we're going to do is take the maximum level of 2 and subtract off our width. Then multiply it by mid. So to begin with, when we have a value of width of equal to 1, we're not changing the signals at all. In fact, 1 times the sides will give us the same exact thing. And also 2 minus 1 will give us a value of 1. We can multiply it by the mid. So this will be a way that we can perfectly reconstruct our signal. So I'll go ahead and run this script and we can see that it works correctly. Now let's say that we'd like to make our stereo field more narrow. So what we'll do is decrease the value of width. Instead of being 1, let's make it something less. How about 0.1? You can run the script again and hear the results. We can also make our stereo width wider by putting a value in here greater than 1. So how about 1.8? So this demonstrates one common way to use mid-side processing to change the perceived stereo width of an audio signal.